All right, so first here, we will go ahead and solve this equation by elimination. We can easily get the y's to be the same if we multiply this bottom one by -3, because then this will be a positive 3y. So when I do that, I will have 5x minus 3y is equal to -4, just the first one written down. And then the second one will be a -9x plus 3y is equal to positive 12. And so now, when I add these together, my y's will eliminate, or if you want to put a plus 0 here, you can. And 5 plus -9x will be -4x, and -4 plus 12 is 8. -4x plus 0 is just -4x, so really the y's just went away, so you can leave that blank if you want. Divide by -4, and we get x is equal to 2, -2. So then once you find that answer, you can plug it back into either one of the original equations. Really, you can plug it into any of them, even these ones down here. It doesn't really matter which one. I usually pick the one with the least numbers, so I'll go ahead and pick this one here. So I'll plug it in there. 3 times x, which we just found was -2, minus y is equal to -4. So then we'll get -6 minus y is equal to -4. We'll add 6 to both sides, and that will give us -y is equal to 2. There's a little invisible 1 here in the front, so we'll divide both sides by -1, and we get y is equal to -2. So our answer here is going to be the coordinate point -2, -2. And it asks us to describe what the graph would look like based off our answer. And so this, because we have a point where we have a solution, that means our graphs are two intersecting lines, and they will intersect at the point -2, 2. All right, question number 2 here. We'll go ahead and solve this also by elimination because none of the variables are by themselves. You could solve it by substitution if you wanted to. And so I'll go ahead and look at the x's, and I want those to both be 3, one to be negative, one to be positive. So I'll just multiply the top equation by a positive 3. So then I'll have positive 3x plus 3y equals -6. And then the bottom equation I'll just copy down again. And then we'll go ahead and add these. Our x's will eliminate or become 0. Our y's will eliminate or become 0. And our -6 plus 6 becomes 0. So then we have 0 equals 0. And this is a true equation. Our x's and y's disappeared. And so then we just ask ourselves if it's true or false. If it's true, that means there are infinitely many solutions. And when there's infinitely many solutions, if we want to talk about what our graph looks like, that means that when we draw the first equation and the second equation, they are exactly the same line. They're right on top of each other. Alrighty, this next one will also use elimination on this one. I'll go ahead and multiply my top equation by -2. That'll make my x's the same number opposite signs. And so my first equation will become -2x minus 4y is equal to -10. My bottom equation will stay the same. And then we'll add these together. My x's will eliminate or become 0. -4 plus -5 will be -9y. -10 plus -8 is -18. 0 minus 9y is just -9y. So then I'll divide both sides by -9, and we'll get y is equal to +2. So then we'll take that and we'll just plug that back into one of our equations. Doesn't matter which one. Could be these two or one of these two. I usually pick the one with the least amount of numbers, so I like this one right here. So let's plug y in there. So I'll have x plus 2, plug in a 2 for y, and we'll get x plus 4 is equal to 5, subtract 4, and we'll get x is equal to 1. So our answer here is 1, 2. And because they had a point or a solution, that means these are intersecting lines. And one of the points is at 1, and the point where they intersect is at 1, 2. And lastly, number 4 here, this is a good substitution problem because y is already by itself. So we'll go ahead and take all of this and plug it in for y here. So we'll have 5x plus 22 minus 5x equals 27. Then we'll combine our like terms because these are on the same side of the equation. 5x plus negative 5x will be 0x. But you also could just write that as 0 because 0 times x is 0. So this will be 0 plus 22 is equal to 27. 0 plus 22 is 22. So for this one, we get all of our x's and y's go away, but we get 22 is equal to 27, and this is false. So when that's the case, if our x's and y's disappear and the equation is false, the answer is no solution. And if it's no solution, then that means there is not a point where our lines intersect. So in that case, our lines are parallel if you were to draw both equations on a graph. All right, let's move on to the 3 equations. So for this first problem here, if I have 3 equations, I need to narrow it down so that I have 2 equations and 2 variables. So I'm going to look at my x's, my y's, my z's, and see which one I think is easier to eliminate first. Here, they're all pretty easy, so you could do x, y, or z. It doesn't really matter. I'm going to go ahead and eliminate z first. So we'll call this 1, 2, and 3. And these 2 would be really easy to eliminate z because that's a positive z and a negative z, so those will eliminate. So we'll go ahead and start with 2 and 3. So we'll have x plus y minus, or plus z is equal to 1, and x plus y minus z is equal to 9. And I need to do this again. I need to pick another 2 equations where it's easy to eliminate z. You can do 1 and 2. That would be fine. You'll just have to multiply one of these by a negative to do that in order for the z's to eliminate. But if we already did 2 and 3, so we can't do 2 and 3. But if I do 3 and 1, those z's will already be ready to eliminate. So I can do 1 and 3 without having to multiply by anything. And then we'll go ahead and add. This will eliminate our z's. We'll have 2x plus 2y equals 10 when we add those together. And then over here, when we add together, we'll get 2x. Technically, your y's eliminate 2, so you can just make that a 0 or leave it empty if you want. But I'm also just going to say, okay, we could write it as 0y. And then our z's eliminate. And 9 plus negative 7 is 2. Now, we may have to take these 2 equations, call this 4 and 5, and solve these equations. We have 2 variables and 2 equations, so we know how to do that. But we got lucky on this one because of the 0y, because that's the same thing as 0. So 2x plus 0 is 2, and we can solve this equation without using elimination. We just divide by 2, and we get x is equal to 1. So then we can take that and plug it into our other equation here and get y. I'll subtract 2. Divide by 2. And get y is equal to 4. So now we have x equals 1, y equals 4. All we need left is z, so then we can go back and plug it into any of the three equations at the top. It doesn't really matter. So I'm going to pick 1. We'll plug both of these values in. So we are plugging in 1 for x, 4 for y, finding z. So we'll get negative 3 plus z is equal to negative 7. We'll add 3 to both sides and get z is equal to negative 4. Now, if you did it in different steps, that's totally fine, but you should get the same exact answer. So x is 1, y is 4, and z is negative 4. All right, so now let's go ahead and do number 6. So if we look at what would be easy to eliminate, I see that the y's would be pretty easy to eliminate. We're going to call this equation 1, 2, and 3. And if we look at which ones would be easy, 1 and 2 together would be pretty easy because they're both positive and negative, and 2 and 3 together would be pretty easy. So we'll start with those. So we'll start with 1 and 2. And then we'll do 2 and 3. And then we'll add these together. So we'll get 2x, our y's will eliminate, plus 6z equals 14. And then over here, we'll get 6x, our y's will eliminate, and 5z plus 1z is 6z. 13 plus negative 9 is negative 6. And now we have two equations, you can call them 4 and 5 if you want, and 2 variables. So none of these disappeared, so we have 2 equations, 2 variables, so we have to solve these 2 equations like we used to. But no problem because we know how to do that. So I'm just going to write them over here. And now we need to eliminate either x or z. And the z's look pretty easy because they're both 6's, but we need to multiply 1 by a negative 1. So if we do that, then the first one will stay the same. And the second one will be negative 6x minus 6z and positive 6. And now when I add these together, I'll get negative 4x. The z's will eliminate. And we'll get 20, and now we can solve for x by dividing by negative 4, and we'll get x is equal to negative 5. And then just like we usually do for systems of equations, we'll take this x and plug it back into one of these equations. I'll pick this one just because I like the numbers better, but you can do either one. So we'll get negative 10 plus 6z equals 14. Add 10 and get 6z equals 24. Divide by 6 and you get 4. So now we have x, we have z, and we need y. So now we have to go back up to one of our original equations and plug it into one of them. It doesn't really matter which one. The first one looks the easiest to me, so I'll plug it into the first one. So we'll take equation 1 and we'll plug both of these values into that equation. So x is negative 5, y we don't know, z is 4, and that should be equal to 1. Negative 5 and 4, we can combine those because they're on both sides. 12y minus 1 is equal to 1. Add 1 to both sides, and we get y is equal to 2. So then our final answer here will be negative 5 for x, 2 for y, and 4 for z. So lastly, we'll do the word problems here. We're supposed to write a system of equations and then solve it. So here for number 7, it says the sum of two numbers is 37. The second number is 3 more than the first number. So the two things in this problem are the first number and the second number. So for part A, we're supposed to write, define our variables, which you just did, and then write equations. So the sum of the two numbers is 37. So if we add these two numbers, x and y together, we should get 37. The second number, so let's call that, so we said that was y. So the second number, y, is 3 more than the first number. So the second number, y, is, that means equal sign, 3 more than the first number. So the first number plus 3. So those are our two equations. And now for part B, we will solve, and remember 3 more here is just plus 3, right? Because if you have a number 5 and it's 3 more than that number, you would add 3. So for B here, we can use substitution. And so we'll plug this in here for y. So we'll have x plus 3 equals 37. Combine some like terms here. So we'll have 2x plus 3 equals 37. Subtract 3. And we'll have 2x equals 34. Divide by 2, and we get x is equal to 16. No, 17, sorry. So the first number is 17. But now we need the second number. So all we got to do is take this and plug it back into one of these equations. I'll pick the second one just because it's ready to go to find y. And we'll get that y is equal to 20. So the second number is 20. So the sum of these two numbers is 37, and the second number, 20, is 3 more than the first number, 17. All right, one more word problem here. 12 of your family members went to the movies. The admission price for adults is $6, and the cost for children is $4. How many adults and children went to the movie if the total cost was $54? So, what are the two things in this problem? We're asking about adults and children, so those are our two things. So x is the adults, or you can make it, doesn't matter which one, and y will make the children. So for part A, we're defining our variable, and then we're making equations. So we'll read the sentences. So 12 of your family members went to the movie. So many adults and so many children all together went to the movies, and there were 12 people. The admission price for adults is $6, and the cost for children is $4. How many people went to the movie if your total cost was $54? So every adult cost $6, so 6x. Every child costs $4, so 4y. And then the total is 54. So now we can, for part B, go ahead and solve this system of equations. Let's multiply. Maybe we'll eliminate the y's. Multiply by -4 to eliminate the y's. So we'll have -4x minus 4y is equal to -48. And then we'll keep the second equation the same. And then when we add these together, we will get 2x. Our y's will eliminate. -48 plus 54 is 6. So then we'll divide by 2, and we'll get x is equal to 3. Then we can plug x equal to 3 into one of these equations. I'll pick the first one. Subtract 3 from both sides, and you get y is equal to 9. So there are 3 adults and 9 children.